here. In the example number 3, simply it is asked about to find out same mass, volume, and number of molecules. But here simply you have to notice one thing differently in this. What is masses of two substances are mentioned clearly. In the previous examples, only one substance mass is given. For example, in the example 1, 1120 kgs are given. Only one mass. In the example 2, 230 grams of sodium is mentioned. But in this problem, there are two masses of two different substances. Right? So this is the difference. Right? So here, when you observe two masses of two different substances, just observe the ratios. Right? According to your balanced chemical equation and according to the question. Right? So let's see how to solve these type of questions. In the example 3, asked to calculate the volume and number of molecules of carbon dioxide liberated at STP if 50 grams of calcium carbonate is treated with dilute hydrochloric acid, which contains 7.3 grams of dissolved HCl. So here, first of all, you have to write down the equation. So here atomic weights already we know. If not given also, no problem. Just we will follow the simple logic to know about the atomic weights. Logically, double to the atomic number. Okay, so here calcium is 40 units, oxygen is 16 units, hydrogen is 1 unit, carbon 12 units, and chlorine is given as 35.5 units. Here the problem is about equation. So you have to complete the equation part. If equation is not given, represent that equation, reaction, and balance it. Right? So write the primary equation to represent the reaction and also balance it if not balanced one. Okay, let's write the equation. So here the equation is what? Calcium carbonate is reacting with dilute hydrochloric acid. So HCl. So CaCO3 plus HCl gives, simple to write the equation. Here it is a base and acid. Calcium carbonate is a base and it is an acid. And one more, it is carbonate family. In the acids and bases, we are learning acid and a base, especially carbonate reaction, will give you salt, water, and carbon dioxide. Salt, water, and carbon dioxide. Suppose, whatever it may be, if you don't know that reaction, there is no problem. Simple. Here, just break it. Combination of these two, first and the last one, right? So its combination is CaCl2. That means according to your 9th class knowledge, Ca2 plus Cl minus. So criss-cross method, you can write like this. So CaCl2. Here minus 1 will be written as 1. So according to HCF, no importance to this. Then here we can write the formula as CaCl2. Right? So like this we can predict. Then one of the composition I got. If there is carbonate, directly you can take one of the product as carbon dioxide. Hydrogen is there. With the combination of hydrogen and oxygen, we will write water. So like this also you can predict that. Okay. So here the products are CaCl2, water, and simply one more is carbon dioxide. There is a mistake in my typing. Here it is actually liquid. Okay, liquid. It is precipitate or aqueous solution you will get. Or sometimes here, how we can, here it may be a gas, but combines with the carbon dioxide, as you are releasing your exhaled air with moisture. So that can evaporate. Okay. So here carbon dioxide and water together also possible, moistured gas. Okay, then I got the equation. Then what to do? What is our first step? Verification. Is the equation is a balanced one or unbalanced? Can anybody find out, is it a balanced equation or unbalanced one?
Unbalanced.
So what do you do to balance it? There is a difference in the counting of hydrogen. Here, look at, and also chlorines. Here, right side, 2 hydrogen atoms, 2 chlorine atoms. Left side, 1 hydrogen atom and 1 chlorine atom, and both together composition is given as HCl. So what you need here? 2. Then automatically you will get 2 hydrogens and 2 chlorines. 2 hydrogens and 2 chlorines. Got it? So what to do? Just you need to put 2 ice coefficient before HCl. That's it. Enough. Now check your equation. Balanced or not? Right side, 3 oxygen atoms, 1 plus 2. Left side, 3 oxygen atoms. Carbon, 1, 1. Chlorines, 1, 1. Then the problem is solved. We have balanced equation now. Then finding the atomic weights of individual reactants and products, individual substances. So CaCO3, is there any coefficient before it? Before calcium carbonate, is there any coefficient? No coefficient, right? So Ca, only 1 atom. So 1 into, okay. So here I am finding only the 3 because here I am not depending on any other. Look at here. According to your question, mentioned to find out carbon dioxide. Next here, clearly mentioned that atomic weights of calcium carbonate and hydrochloric acid gas is given. Right? Then what to do? So I'm using only these 3 to find out. Actually, you know the method verifying that masses before the change and after the change. It is very easy. You can do it. So here calcium carbonate, find out Ca, only 1 atom is there, 1 into 40 plus C, 1 into carbon atom is 12 units plus 3 atoms of oxygen, 16. So what do you get? 40 plus 12 plus 48. It gives you 100. So directly written here. Got it? Clear to you, everyone? Clear to you, everyone? Yes. Now we will go for HCl here. 2 into, here it is multiplier, coefficient. So take it as whole. The next HCl, H 1 unit, Cl is 35.5. That equal to 2 into 36.5 equal to 73. So here 2HCl will give you 73 grams. On right side, I need only carbon dioxide, CO2, C plus O2. So C is 12 and 2 into 16 will give you 12 plus 32 equal to 44. Are you clear about this one? Directly what I am giving you. Is it clear? Yes. So let's see what to do. Just observe closely. Here, calcium carbonate is 100 grams. HCl is 73 grams. Right? According to our balanced chemical equation, 100 grams of calcium carbonate reacting with 73 grams of HCl to produce 44 grams of carbon dioxide. Then, according to the question in the problem, there is only 50 grams of calcium carbonate and 7.3 grams of dissolved HCl. But here I am taking 36.5. Why, sir? Here look at 100 grams, reduce it to 50. Just it is half, reduce it to half. Then here also I am following the same ratio. According to law of constant proportion, the ratio always equal. So reducing to half, I am required 36.5. Are you following me? Right? Here, according to the question, calcium carbonate is 50 grams. So here, according to that ratio, as per law of conservation of, law of constant proportion, the same ratio maintained. Whatever it may be the quantity you are providing, it won't. It always combining with the other substance in the same ratio. So it must be combined with 36.5 grams of HCl. But in the question, they have given only 7.3 grams. Is it correct ratio? Proper ratio? Are they given in the proper ratio? No one responding. Are they in the proper ratio? No. So here what to do? We have to observe which is available less in quantity. In the both calcium carbonate and HCl, which is available less than the required quantity. Actually, required quantity is 36.5 grams, but the given quantity is 7.3 grams. So available less than the required quantity. Yes or no? So here simply 7.3 grams of HCl will affect the product, carbon dioxide here. So what amount of carbon dioxide will be liberated with 7.3 grams of HCl? Right? So here we are not depending on the calcium carbonate because it is given extra quantity comparing with the HCl. HCl is given less quantity comparing with the calcium carbonate. So we will go for less quantity because here it will affect the product. The substance which is available less in quantity will affect the quantity of a product. So if you want to produce that product with the same quality, what to do? That quantity we have to increase, but given less in quantity. So according to that, we are reducing the quantity of product. So that HCl will reduce the quantity of product. So we will take here 7.3 grams as our relation. So here we are not depending on the calcium carbonate. We are depending only on the HCl on 7.3 grams. So substance which is available less than the required quantity is known as limiting reagent. This is called as limiting reagent. So that can limit the product. So we are depending on the HCl to produce carbon dioxide. So what amount of carbon dioxide liberated when 7.3 grams of HCl reacting with the calcium carbonate, whatever it may be the amount. Our question is changed same as like first or second example. We are not depending on this 50 grams of calcium carbonate, 7.3 of HCl. We are depending only on what amount of carbon dioxide liberated when 7.3 grams of HCl reacting with the calcium carbonate. Simple. We made it. And also, I have relation. HCl to carbon dioxide. 73 grams of HCl producing 44 grams of carbon dioxide. What about 7.3 grams of HCl to the carbon dioxide? So this is our relation. Then we know, according to law of conservation of mass, that cross products are equal. So we will take X into 73 grams is equal to 7.3 into 44 grams. That's it. Then transposing. So here on transposing, that 7.3 becomes denominator here. Next, cancellation. Sorry, I made a mistake here. There is a mistake. 73 written as 7.3. No, it is 73. Right? It is 73 grams. Now cancellation. So 7.3 grams one time, 73 10 times. Multiply. So 10 times cancelled. Then what is remained? Here 44 grams by 10. That equal to what? So X is equals to, we will get 4.4 grams. 44 by 10 equal to 4.4. So I got it. X is equal to 4.4 grams. So here what is 4.4? It is the atomic weight of carbon dioxide liberated when 7.3 grams of HCl reacting with the calcium carbonate. So that we can write. On reacting 7.3 grams of HCl with 50 grams of calcium carbonate, producing just 4.4 grams of carbon dioxide. Are you clear how to select the limiting reagent? How to deal these type of problems? Everyone, give me your response. Are you clear or in confusion? So everything is looking good. Okay. So now let us move to another. Finding molecules and volume. So here, which you will consider now? Which substance, molecules, and the volume you are finding? Which substance, volume, and molecules you are trying to find out? Carbon dioxide, calcium carbonate, HCl. Among the three, which you are going to select? Tell me. Very good. Carbon dioxide. So we have to find out carbon dioxide. So here we have solved that atomic mass. So 7.3 grams of HCl produces 4.4 grams of carbon dioxide. According to your balanced equation, what the mass is calculated here? 44 grams. So what is 44 grams? 1 mole or 2 moles? 1 mole or 2 moles? Or more than that? Number of moles of carbon dioxide is representing 44 grams here. 1 mole, 2 mole, whatever it may be. Tell me.
1 mole.
How you decided it is as 1 mole? Give me clarity.
No coefficient.
Very good. Simple logic is no coefficient. Okay. If you don't know this logic, how do you find out? If there is no logic given to you, I am not given any logic. How do you find out number of moles of carbon dioxide?
Number of moles equal to mass given by molecular mass.
So weight is given according to your balanced equation and molecular weight. Also, you can call it as gram molecular weight. So here it is weight 44 grams and molecular weight also 44 grams. Then you will get what? 1. So like this, we can calculate. Right? So I think it is clear to you, everyone. Raise your hands if there is any doubt. Otherwise, go to quick impression. Are you in doubtful about this? Okay, clear. Now, look at here. I know gram molecular weight of carbon dioxide. So 1 gram of molar mass is equal to what? 44 grams. So 44 grams of carbon dioxide gas at STP occupies 22.4 liters of volume. Then what about 4.4 grams of carbon dioxide occupying? I don't know. That is taken. Why? unknown quantity. So here, according to law of constant proportion, cross products are equal. So y into 44 is equal to 4.4 into 22.4 liters. Then transposing. So on transposing, 44 becomes denominator here. Okay. Then cancellation. Units cancellation first. Grams cancelled. Then values cancellation. Here 4.4 one time and 44 is 10 times. So what you got? 22.4 by 10. That equal to simply 2.24. So y is equal to 2.24 liters. Y is equals to 2.24 liters. So what it is? Volume. So 44 point, 4.4 grams of carbon dioxide occupying 2.24 liters of volume. Here 44 grams of carbon dioxide occupying 22.4 liters. Now look at here, simply 44 to 4.4 ratio 1:10. Is it 10 times reduced? 1/10. Is it or not? Right. So 1:10. So here reducing 10 times. 44 reducing 10 times will give you 4.4. Is it or not? 44 into 1/10 equal to 4.4. Then here that same thing I will apply to this one. 22.4 also reducing 10 times. That what exactly you got in your answer? See here, 1/10 into 22.4. Logically, we can solve directly. Got it? Molar concept. Everyone is clear? How to solve logically? Yes. So now we'll go for finding molecules, number of molecules. So we concluded that 4.4 grams of carbon dioxide occupies 2.24 liters of volume. Then what about number of molecules? Same, depending on the gram molecular weight, 1 gram molar mass, that is what? 44 grams of carbon dioxide. So 44 grams of carbon dioxide contains 6.023 into 10 to the power of 23 molecules. Then what about 4.4 grams? Z molecules unknown. I'm using XYZ, X for mass, Y for volume, and Z for molecules. Okay, so here now again the same law of constant proportion. Cross products are equal. So Z into 44 is equal to 6.023 into 4.4 or 4.4 into 6.023 into 10 to the power of 23 molecules. Then on transposing, what we can write? 4.4 into 6.023 into 10 to the power of 23 divided by 44. Then cancellation here. Simple technique. Grams cancelled. Then 4.4 one time and 44 is 10 times. So what I got? 6.023 into 10 to the power of 23. Don't cut here. Directly cancel with the 10 power 23. So here 10 power 23 divided by 10, that is equals to 10 power 23. The 10 taken into the numerator will be written as 10 power minus 1. What equal to 10 power 23 minus 1 will give you 22. So this you have to solve mathematically. Then finally we can write Z equal to 6.023 into 10 to the power of 22. 6.023 into 10 to the power of 22 molecules. So here simply 4.4 grams of carbon dioxide contains 6.023 into 10 to the power of 23 molecules. Got it? Everyone, is it clear? Is it clear?
2 moles of dioxide contain how many molecules?
2 moles of
Carbon dioxide.
simple. Here, what we decided, 1 mole is equal to what? 44 grams. Is it? You are saying 2 moles. It must be 88 grams. Okay, sir, not given about masses, sir. Only asking 2 moles of carbon dioxide occupies what amount of volume. Okay, simple. Into 2. Here also, same. Into 2. What you will get? 44.8. Here, 12.046 into 10 to the power of 23, reducing to the 1 decimal, 1.2046 into 10 power of 24. That's it. Very easy one. Got it? Number of times you are multiplying to this one. This is a very, very important thing. 1 gram molar mass of any substance occupies 22.4 liters of volume. For any gas, 1 gram molar mass, that is not 44 grams, depending on the substance. For example, here, if a relation is given between H2 plus O2 mu is less to CO, H2O, is it a balanced one? No, unbalanced equation. Make it balanced one. So here 2 and 2. So here it is 1 mole. Here it is 2 moles. Here it is 2 moles. This is molar relationship. So here simply, if someone asks you what amount of volume occupied by hydrogen, if hydrogen mass is 8 grams, tell me, 8 grams of hydrogen, I am asking you. Already balanced chemical equation is given you. 8 grams equal to how many moles? That you have to find out. No need to depend on your balanced equation also. No need. Why, sir? Here, simple. Suppose hydrogen asking. Hydrogen molecular formula is what? H2. Then its gram molecular weight is 2 grams. How many grams is given? 8 grams. So 8 by 2 equal to what? 4. So 4 moles. 1 mole equal to 22.4 liters. 4 moles equal to into 4. That's it. 1 mole is 6.023 into 10 to the power of 23. 4 moles into 4. Just you need to multiply the given values. Avogadro volume and Avogadro number. What is Avogadro volume? 22.4 liters. What is Avogadro number? 6.023 into 10 to the power of 23. That's it. Are you clear? Everyone. Answer is suitable to the question or not? What I am given explanation, is it clear to you, everyone? Yes. So are you satisfied with me?